the most part, you guys should have like a grasp on this stuff, I think. See, well, we're just doing it just because, okay? So, same idea. The learning goal here is that we're able to use y equals mx plus b to graph a line, okay? And then I'll do a little bit, a couple spin-offs of that concept. So if you were given like 2 points, you could solve for what the equation of the line was, and then that would be useful, right? So that's the ultimate goal. We're looking to identify the slope from the equation, okay? The y-intercept from the equation, and then we want to be able to determine the slope between 2 points, and then rewriting. This is where lesson 1 is going to kind of take its turn here on. It's going to come back. Is rewriting an equation into y equals mx plus b, okay? So you can see how like I only have one thing on the left side. We're going to have to rearrange the equation to get it to look like that. Is the concept from lesson 1, okay? So let's take a look here, okay? So the equation of a line is y equals mx plus b. That's kind of an important one. It can come back up in the 3U depending on how much time the teacher has, okay? They start combining lines and parabolas, which we're going to do here, okay, in the course. But you basically have 3 methods for a line, but you have multiple methods to plot graphs, right? This goes like, the first one always works, doesn't matter what the equation is, doesn't matter what the function is, like, is fundamentally works. You can do it with anything, okay? That's what we call a table of values, okay? Okay. It's probably the slowest of the 3 forms. It's kind of like your last resort. If you don't know what you're doing, you can always use a table of values to produce the graph. Always. Doesn't matter what the function is. It's a line, it's whatever, okay? The second way you would have seen last year would have been slope slash y-intercept, okay? That's the y equals mx plus b. And then the third way we can use this, remember, what's kind of the fundamentals with a line? What do you need to create a line? Just 2 points, okay? 2 points lock down a line. 1 point, the line could go anywhere. But a second point locks it down. Then you know it has to go through both of them. That it's just a line, right? So it doesn't matter what those 2 points are, okay? It just needs 2 points. So that kind of forms the foundation of the third one and what we call it's x and y intercept, right? So x and intercepts. I'll spell out the whole word here. Okay, they're just 2 points. So you're going to have like a 0 and a y value, and a 0, oh, sorry, an x and a 0. Okay, that's just words, right? I'll show you actually like an example down at the bottom where we can use that. But for the first one, it wants us to use the very first method, and right, so with this, I think what I want to highlight is like, this is always going to work, but it's the slowest method. Okay, like when we teach you things in math, we're trying to teach you the quickest way to solve a problem, okay? But we got to lay the fundamentals. That's what the table of values is. It's a fundamental, like, it produces a picture, but it's not the best way to do things, okay? It just takes too much time, okay? So we're going to do it here for the purposes of, like, just showing or laying the foundation, okay? So the way, like, any function works, it doesn't matter if there's a 3 or, like, a 4, or it doesn't matter. This is what I was getting at earlier. This is like as easy as they come, a line, right? The point is, you can always create a table of values and pick points that you want to plug in. Okay? I like picking things around the origin, or like 0, 0, as close as I can to get at least a picture. So you could go -2, 0, 2, even 4 or something like that, right? Now, in the past, I have discussed these things in the sense of being kind of like a little machine, okay? Where like any machine, you're going to have things that you put into the machine, and on the other end of the machine, it spits something out, okay? So with that in mind, we have things that we input into the machine, X values, and it's on the other end, it spits out Y values. So we call like function machines. This is just a very basic function machine, okay? We input things, it spits out outputs. Okay, so by using a table of values, okay, I'll show you the first one and then we'll just write down the rest of them. You can confirm them, okay? Y equals -3. I'm going to plug in the X values and they're going to spit out Y's. Okay, and then I have ordered pairs. I have points on the graph that I can go and plot, and that's how I create the picture, right? So -3 times -2. I'm going to plug in the first one, okay? Plus 7. -3 times -2 is 6 plus 7 should equal 13. Okay, I'll do a second one because that's not really necessarily a great point. It doesn't fall on my grid. Okay, so we'll do the second one. Y equals -3 times 0 plus 7. These are easy ones. These are what we call like trivial solutions because you just plug in 0 and see what number you get basically, right? So Y equals -3 times 0 is 0, so that's like a wash, right? So Y equals 0 plus 7, which is 7. Okay, in theory, I now have 2 points that I can plot and create my equation or the picture of my line. Okay, but sometimes like you can find 2 points that are kind of close together. It doesn't really necessarily give you the whole picture. Like you're gonna have to overextend the line, right? So if I were to go plot these 2 points now, right? When I plugged in -2 as an input, it spat out 13. Okay, when I plugged in as an input 0, it spat out 7. Okay, you can keep going. I guess I'll do them all. Okay, spits out 1. And then when I plug in oh boy, -3 times 4 plus 7, so -12 plus 7. Okay. Can you imagine having to do that like 6, 7 times, 8 times to get a picture of a graph every single time on a 10-question test? Can you imagine doing that? It's not the best way of doing it, but it works, right? I show you it because it works, and then I try to illustrate that like you don't want to do it that way, so we're going to do it the other ways that I'm going to show you, right? That's why Y equals mx plus b works. That's why we have that. That's why we use it, right? So I can go plot these things now. -2 and 13 would be somewhere up in here. Then I could plot 0, 7. And then I could plot 2 and 1. And then I could plot 4 and -5. Not perfect, but close. Okay, there's your line. It's not perfect because my first point's off, right? It should go through all those perfect. So we have any questions? That's a table of values method, or a function machine, as I've come to learn. You could even say, I like using the terminology of function machine. I'll do a different color here. It's just not the quickest, that's all. Okay? Is everybody okay? So, if we go down, this is where we're gonna like, I'll leave that there for a sec. This is what we call y equals mx plus b. This is method 2 now. Okay? So I like identifying the information that I can see visually right off the bat, right? So by writing the equation, and there's a reason why I've written it right above, okay? Here you can see m, and you can see the b value. Do we remember what m and b are? Good. Okay. M is slope. This is the Y-intercept. Okay. Now that's great to identify it, but we still don't necessarily know what it means. The Y-intercept is where the graph crosses the y-axis, intercepts it, right? Crosses. So it crosses, if I say m is equal to 2 and b is equal to, is it 6 or negative 6? It's negative 6. It takes the sign that's on it. Okay, if it was plus 6 there on the end, it would take that, but it's negative. Okay, so it's negative 6. So that just means I get to go down to the, remember y is this, the y-intercept. It's crossing the y-axis at negative 6. That's like your starting point. So we'll find negative 6 and put a point right there. Okay. Now, the slope, do you remember how we used to say what the slope was? Does that sound familiar? Rise over run? What's the problem with just a number of 2? Just have a rise, right? So I, in theory, just have 2. But I can always put anything, any number, it doesn't matter what it is, I can always put it over 1. Now I have a run, right? Because 2 divided by 1 is still 2. So now I can start at my starting point. I go down and I find my starting point here at negative 6. My m, my rise over run, is 2 over 1. That just means I'm going to go up 2, right 1. They're both positive, right? So positive x goes this way, positive y goes that way. Negative x goes that way, negative y goes this way. Because they're both positive, I'm going up and to the right. Okay? So, just going to count 2 up from negative 6 to negative 4 to the right 1. There's a point. Up 2 to negative 2, right 1 to 2. Up 2, right 1. 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 Look how many points I just found. I just found like, I don't know, 2, 4, 6, 8, 9 points. 8 points in less than 10 seconds. Whereas if I use the table of values method, look how long it took me to find 4. That is like when we show you things in math, we show you the fastest way to do things. Doesn't mean that the stuff that you've learned in the past doesn't work. It's just ultimately, you don't want to sit, if you're an engineer someday, you're not going to sit there and take the amount of time to find all this stuff, right? You're going to want to do it in the fastest way possible and still yield the most accurate results too, right? So then you can just connect all the dots. That one was a little bit better, right? Because I didn't guess on the last one. That make sense? That's a better way of doing it, okay? The next one has an issue with it, okay? This is what we call like so this method was what we called like slope Y-intercept form. This guy over here is what we call standard. A little harder to use, okay, and it's in the way that it's written. Okay, it doesn't look like y equals mx plus b, that's for sure, right? So that we can fix though with the stuff we did in the first lesson. How do I make this? How do I make this equation look like this one? That's what I'm trying to do, so that I can just do exactly what I just did in the first question. I'm going to change the way that it looks. If I were to change the way that it looks so that it's useful, I want to isolate for y on the left side. Right? I want it to make it look like this one, where y is isolated on the left side. We know how to do that because we just finished doing it in the first lesson. I'm just going to isolate for y. Doesn't matter that there's an x in there. It doesn't matter. I want y. Okay? So all you have to do is just start moving stuff over to the other side. So right off the bat, I see I can add 12 to both sides, right? So that leaves me with, the 12s cancel on the left, 4x plus 3y is equal to positive 12. Okay? Then, if I'm after y, that means I'm just going to leave the y piece, or whatever's there with y, alone for a sec. I'm going to subtract 4x from both sides. That wipes those guys out. Now I've got 3y is equal to 12 minus 4x. Getting close. How do I get just y by itself? Divide both sides by 3. Now the 3's cancel. You get y equals 12 minus 4 over 3x. Are we there yet? Does it look like the other one? It's a little bit messier, right? What you can do, there's nothing wrong with this. There's a plus sign in front of this 12. Why can't you switch the order of these two things? Y equals negative 4 over 3x plus 12. Okay, that looks pretty good, I think.
Why is it still 12? 8 divided by 3.
Oh, you're right. Sorry, buddy. Yeah, didn't do that. You're right. You guys got to call me out when I make a mistake. What should it be? Remember, so what he's saying, yeah, it's 12 divided by 3. I just didn't write it. I just got ahead of myself. 12 divided by 3 is right here. What is that? That's my fault. Sorry. It's nicer because it's a smaller number now. Okay. So, if I were to rewrite on top of this, y equals mx plus b, I could then now find m, and I can find b. Right? So m is equal to negative 4/3, and b is equal to 4. M is your slope, b is your y-intercept, so where am I starting? I'm going to go find my y-axis, my y right here, right? Where do I start? At the b value of positive 4. So you just go find it. Okay, so here's where I start, right there. Now the slope with this one's a little trickier because it got a negative in there. But does it matter where the negative is my question. And by that I mean, like, does it matter if it's in the top or the bottom? It does make a difference, but not to the whole picture. Okay, so we'll do one here. Okay, so we'll start at our starting point and we'll say m equals negative 4/3. Okay, which means in terms of rise over run. Which means I'm going to start at my starting point of 4, right? And I'm going to go down 4, but the bottom is positive, so I'm going to go right 3. So let's just count down 4. Going from positive 4, I'm going to count down 4 to 0. 1, 2, 3, 4. Right 3. 1, 2, 3. Then I'm going to do it again. 1, 2, 3, 4. 1, 2, 3. You can keep going. You kind of get the picture, right? 1, 2, 3, 4. 1, 2, 3. Okay. Good. Does the line just stop here at the y-intercept? It does go, in theory, up to the left more, right? So, like, in theory, you're going to have a piece of the line go up here somewhere. Well, what's its slope? How do I get the points on that line? You just flip the negative. So it's positive 4 over negative 3. That's still negative 4/3. If you were to type it in a calculator, you'd still get the same number, negative. Except this time, I'm going to erase this. I'm going to go up 4, 1, 2, 3, 4, left 3 because the bottom's negative. 1, 2, 3. And I've kind of run out of room. 1, 2, 3, 4. 1, 2, 3. Something like this. Okay? Do we have any major issues? Again, we're still kind of like in the review stage, right? Just trying to solidify some skills here for you for when we move on. Like lesson 5 on is a little bit new material, okay? Even 4. Okay, so we're just trying to lay the skills here for you. Okay, is everybody okay? You tell me when I can move on, okay? Everybody's good? I'll move on. Again, much faster than sitting there and typing in points in your calculator. And probably more accurate in the sense if you make a sign error in your calculator, you're going to get a wrong point on your graph, which messes up the picture. Right? It's more reliable too, I'd say, this method. Okay? It's not a bad method, but you will learn that there's a better one. Okay? So this one here, you've got a picture. You've got the graph. I want to go backwards. So I want you to tell me, like we're trying to develop what the equation is from the picture. Okay, how are we going to do that? Yeah.
Find 2 points on it and then just figure out the slope from here.
Right, okay. The last question is finding the 2 points, but you're right. We're still going to find 2 points. But I'm going to pick one of the 2 points that I'm about to pick are going to be very selective and deliberate. Okay. Yeah. One of your points, you're gonna deliberately pick the one that goes through the y-intercept because that has 2 purposes. It gives you a point It also identifies the B value of the line. Right? So again, the y-intercept is where the graph crosses the y-axis. This thing. At what value does it cross the y-axis at? Positive 2. Which makes your B value 2. So now you got half the question done. That's why I mean like you're selecting one very specifically. Okay? Now from here, you're looking for another point that directly passes through the grid lines. You know what I mean? I'm not looking for one that goes through the middle of the boxes somewhere because that's not useful. That's guessing. You're looking for like any other point on the graph that the line goes directly through a grid lines cross, where the grid lines cross. Okay? So just, you could pick any of them. It doesn't make a difference. The one I grabbed my eye would have been that one, or 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 that one. You can pick any of them. Then your job is, from that point, to figure out how do I get from my starting point to any of those. Doesn't matter which one you pick. The number's going to work out to be the same. Okay? So if I were to go, I'm just going to pick this one. It doesn't matter, but if I pick this one, how do I get to that point? I go right 2, down 1. Right 2, down 1. Sorry. Don't write that down. I'm getting too excited here. Yeah, I did the wrong way. As soon as I wrote rise over run, I fixed it. So remember, I should have wrote rise over run. I was getting too ahead of myself. So you got to go the up down first. Rise. Okay, so I'm going to go down 1, right 2. That makes sense? My bad. Okay. That is your M. Rise over run. Okay. What is the equation of a line? Y equals mx plus b. You know M. You know B. You just have to plug them in, and that's it. So your equation for this line that's on this grid is y equals negative 1/2 x plus 2. That equation will give you what the graph, where the graph is at x equals 1 million if you wanted it. Something you're never going to you're never going to plug in x value after x value to get to 1 million, right? But if you wanted to know what the y value was there, like our question from this morning about like how much chocolate's in the drink, we could plug in the value and find out how much or how strong